Are looking live at room 204, Heartland Christian School. Pre-algebra on this frigid December morning. Friday the 13th. Year of our Lord 2019. Since we have no Triskaidekaphobics, we are okay. Who's behind Bella?
Rachel, she's not here.
No Rachel and no Jordan. All right. Yesterday you did 7 through. Hello. Am I even here? 7 through 28 on pages 264 and 265. And today you're working on 29 through 50 on page 265. So here's what we'll do. Get right to work. You can get right to work on 29 through 50. However, if there was something about 7 through 28 that you didn't understand, please raise your hand. I did a lot of them on the board yesterday. If there's still lingering questions, you need to ask. Help me help you. I can't help you if I don't know that you don't know.
29.
So right out of the gate, Dina says, I'm having a little trouble getting going this morning. Could you do number 29 on the board? Where's my board? What's it say? Okay, shh. Not recess, activity period, even study hall. Brett, we're going to do 29 on the board to get you out of the gate. Are you ready, David? Yeah? 5, 6, X. When they're written right next to each other, what's that mean, Dina? No. When it's 5, 6, you're going to multiply those two together, and it says it equals 25. So Dina, knowing her 2 basic axioms of algebra, remember that word? You can undo addition by subtraction. You can undo subtraction by addition. You can undo multiplication by division. And you can undo division by multiplication. Here they've multiplied the two together. We can undo it by dividing by 5, 6. We understand, because that first question in the review, we understand that a reciprocal are 2 fractions multiplied together that give us a product of 1. Well, why is that important? Because if we divide by 5, 6, we're actually multiplying by 6/5. So here's how that works. I'm going to multiply both sides by 6/5. Let's stop there. How do you undo multiplication? Dina says this is 5, 6 times X. How do you undo multiplication? You divide. When it comes to fractions, you never actually divide. You multiply by the reciprocal. That gives us how many X over here? What's a reciprocal do? It gives us a product of 1. What's this going to equal if I multiply 6/5 times 5, 6? 1. That's what I want to know. So I got X over here. Whatever I do, the other axiom is, one side of an equation, I must, so I multiplied this side by 6/5. Where you're getting messed up right now, Dina, is you're forgetting to bring into your, you know this, when you multiply, or when you divide by a fraction, you actually multiply by the reciprocal. So look what happens when I do this. 1, 1, 1, 1. Oh, it's such a beautiful place where everything turns into a 1. Because they, what, honey?
How does that equal 26?
No, this is the original problem. So I'm multiplying this side by 6/5 and this side by 6/5.
Cool.
Once again, what's the 2 basic tenets of algebra? You can undo any operation by doing the opposite and do it to both sides. That's it. Right now, we just started this. Remember when you did in 5th grade? There's that one lesson. If you just remember those two basic things, you undo what they did to the variable by doing the opposite. Do it to both sides. The key to this one, though, Elise, is understanding that when you divide by 5/6, you're actually multiplying by 6/5. What's the point to the reciprocal? First question on page 264. It has a product of 1. That's what you want, Evelyn. You want to know what 1x equals. Right, Mitch? So 25 times 6/5 is 30. Number 29. And now you're on your way. We'll do number 30. Is that what you're going to say?
No, I got
Oh,
30 down.
sweet.
Please see if I do 30, right?
So apply the same principle to number 30. How are you going to get rid of the 2/3? You're going to divide by 2/3, what actually means you're going to multiply by
the
3
reciprocal.
over 2, because that means everything cancels each other, and it turns into 1b. That's what you want to know. What's the value of the b? As long as you multiply the other side by 3/2. So the answer to the question in number 30 is b equals
1 1/3?
8/9 times 3 over 2.
Yeah.
What'd you get?
4 over 3. So then 1 over, 1 and 1/3.
1 1/3.
Yeah. That's what I was trying
David,
to
32 coming up.
Yes.
Excuse you. Oh, I gotta stand here and memorize all these numbers. I'll write the numbers first. 2 3/10, 11/5.
I'm so confused. That's number 33.
Oh, David, that's not what you're looking for. I'll leave that up there, though, just in case. Number 32, 4 9 8 plus 4 1 2.
Probably change that number though. Yeah. Oh,
I
well,
forgot the
actually
number.
needs 33, so you have to test.
There's a whole lot of chatter going on outside of math. Let's focus so we can be ready for test day. Friends. Okay. All we're doing here is, instead of in one step solving the problem, we have to do 2 steps. Because the first thing we have to do is to isolate the variable term. We want to get rid of, first thing is, get this 4 1/3 out of there. How do I undo plus 4 1/3? I subtract 4 1/3. So the first thing I'm going to do is say, this turns into 4/9 A, and if I go like this up here, I can save a little space, minus 4 1/3. So 4/9 A is going to equal 5 2/3 minus 4 1/3, which is 1 1/3. Another way I can write 1 1/3 is 4/3. I'm not going to change to a decimal. I'm dealing with fractions here. Do you mind if I change 1 1/3 to 4/3? Are you following this, Zacchaeus? Bella, 32. Can you focus here for a second? Do you see what I'm doing? Getting rid of the 4 1/3 by subtracting from both sides. That gives me 1 1/3, but I'm going to change this to 4/3. Got it? 1 1/3 is 4/3. Now, how do I get rid of the 4/9? Now we're back to this. I divide by 4/9, which means I actually multiply by 9/4. So if I multiply by 9/4, that gives me A. Multiply by 9/4. Look at this beautiful stuff. A is 3.
A is 3.
Yes.
I'm just trying to. See, my hands are closed. If they were open, I'd be.
Gotcha.
Now.
My hand's closed. It's foul. It's open. It's violation.
Sure.
So when you're watching the game, you see the referee go like this. You know, oh, he's calling foul. You see the referee go like this. Oh, he's calling traveling. Out of bounds. This is violation. This is foul.
She's violating her.
This. Okay. Still, Cam. We're not focused. All right. The sure-proof way of comparing numbers is giving them the same name. We've got mixed numbers and we've got mixed decimals. So I got to choose a strategy how I'm going to compare all these numbers by giving them the same name. Am I going to turn them all into decimals or am I going to turn them all into fractions? You with me here? This is number 33 on the board. I got two choices. Turn them all into decimals, which is going to allow me to see them all and compare them as decimals, or turn them all into fractions, which will also allow me to see them all. I am going to choose to turn them all into, what do you think?
Fractions.
No? Decimals. Because I see I could turn this easily into 2.3. I could turn this into, this is 2 1/5. I could turn this into 2.2 because surely by now I've memorized my fifths. 0.2, 0.4, 0.6, 0.8, right, Jaden? This is 2.32, so watch what I do here. Since this goes to the hundredths place, I'll put zeros behind these so they're in the hundredths place. This is 5/2, which is 2.5. 2.50. This is already set up for me, and this is 2.00. Now I've got all my numbers with the same name. And now it's just a matter of 2 is the smallest, 2.20, 2.25, 2.3, 2.32, 2.50. 33. I changed everything to a decimal, Cameron, because when I looked at this list of numbers, I noticed it was going to be way easier for me to determine the decimals than to, look, I got 3 different denominators there. I would have had to change everything to like something over 100, which would have been all right, but this was easier for me because I know my fifths, right? And I know that this is 0.3. I know my tenths. So I changed them all into decimals. And now look how easy it is. Smallest. So we go from, they want me to go from largest to smallest to largest. Okay, so I go 2, then
2.20.
I'm sorry. I'm going to rewrite them as they were in the problem. 11 fifths. 2.25, which is how it was written. 2.3, which was 2 3/10. 2.32.
Which is 2.32.
And 5/2. There's number 33. As they were given to you in your book, rewritten from least to greatest. You still don't like it? Math's a beautiful thing.
That's what my mom says, but I disagree.
Math's the language of science. Science is the pursuit of knowledge, and knowledge is good. Knowledge is power. Power leads to influence.
Knowledge about God is
Abused, misused power can lead to communism. Power in the wrong hands could be bad. Power and influence in your hands, I hope, would be really good. Because you would lead people into the kingdom, right? So that's a really good thing. Power in the hands of the wrong people leads them astray. For instance, communism, since you brought it up, would lead them to put more faith in government than God. First thing the communists do is eradicate God from the public square. Because if you become more reliant on government than God, then they can become all powerful. They can be your all of your provision, support. That's why the people that are in politics and they constantly try to get people to believe that socialism or communism is good, and it sounds really good. Everybody has a home, everybody has food, all that sounds so good, but really the end of that is evil. Because then nothing's free and everything's provided for you by them. No, not in socialism or communism. Everything's provided for you by them. So then they become your source. Make sense? And then they play a simple little game, right? Nothing in this world is ever going to be perfect. So the opposite of communism is capitalism, which we believe in, freedom, right? Is it perfect? No. So all they do is point out all the bad stuff and get people to believe that it's bad and then follow them. It's a pretty simple game, really. Are most people rich?
No.
No. So how easy is it to convince someone that's not rich to go against the rich? It's a pretty easy thing. That's why they have as much support as they do. Why it's a threat. It's pretty easy. I don't have a lot of money. You're going to convince me that you're going to take it from someone else and give it to me? Oh, good, thanks. I'll vote for you. It's kind of like third grade stuff. But people buy it. And that's our socio-economic lesson during free algebra today. Hey, it all comes together in the end. English, math, social studies, science. It's all one big ball of knowledge. Here he waits to help you. Help me, help you. Are you acting like you're done?
No.
Yes, you may use the restroom. So are you talking about a fraction and you're using the fraction bar as a division sign?
Yeah.
Okay, so Dina, how many times have I said this? When I was your age, I had to get this rhythm in my mind. What is it, 5/12?
Yeah.
5 divided by 12. Literally, that's going on inside my brain when I write that.
I'm doing that. How many times have I
You mean 12 going to 50?
Yeah.
Your times table tells you 4, doesn't it?
Yes.
Okay, here we go again. Get loud with no questions. That means everybody's acing. I mean, not getting an A. Like, you know everything there is to know.
Nope.
Chapter 5.
Sure.
Yeah. During our double our pleasure next Thursday. And then we're not together next Friday. That means you have to go an extra day after this extra long Christmas break without getting to see Mr. Frank, and you're going to miss Friday too.
No.
And listen, a lot of times, 5th grade, when there's a long extended break, kids like get the shakes and stuff at home, and they cry at night to their mom, I haven't seen Mr. Frank in 7 days.
No, I did that in a year because I couldn't see for an entire year.
So then my phone will ring and I'll answer and I'll just hear sobbing and they're afraid to talk and then I'm like, who was that?
Oh, this is annoying. I don't want to do this.
Neither do I, but we got two.
Wait, is it .375? It's really good.
Are you talking about 3/8? You got that memorized, don't you? You've got your 8. Jonathan,
Yeah, totally.
give me your 8s. Ready? 1/8? Yes. Go ahead, Ethan. Okay, Brett.
175.
Brett, hold on. Brett Walker, sports stats guy, is going to tell us our 8s. Ready? Brett, what's 1/8?
1.25.
Not 1.25, but 0.125? All right, 2 8s.
250.
3 8s.
.375.
4 8s. 5 8s.
Oh, I
7 or 6 8s.
0.750.
7 8s.
0.875.
There you go.
.7.
And of course, 8 8s says you'd be batting 1,000, 1.00.
Yeah, actually, I do remember that. It's actually really easy because then it goes 1, it's 1, then you go 1 to 5.
Brett, your next mission
3, 375.
is to memorize your 7ths.
No.
Just in case you draw a walk in game 1, you go 2 for 7. You know you're batting 286.
No, thank you. I won't.
7ths, you basically count by 143.
I'm literally only on 34. There's no way I'm going to make it to
429.
process.
If you're 3 for 7, you're batting 429.
Yeah.
Huh?
What was the number then?
Okay.
Or if you're doing basketball stats, if you make 3 out of 7, you're shooting 42.9%, 43%. What? From the foul line?
I was so.
Oh,
No, it's not too bad from the field. No. So did you guys play 7th and 8th last night?
I did.
No, did Heartland play?
Yeah.
So 7th grade won
Yeah.
and 8th grade won.
No. Because
What was the 8th grade score?
It was
it was like 33 to like
Really?
like 5.
The refs weren't that bad. They kind of lost because they wanted to go. And then it's not that
What was it?
I don't care. At least we won.
70.
It was 33. And it would have
I'm better than you.
No, you don't.
Wait, we have a huge disparity, and 2 kids that played in the game, one's got the score only being 37-33, and the other one's got it being 52-47.
The final score is 42 to 37.
42-37, okay. That's not.
Yeah, we lost it by.
Our game was 37.
Only 4-4.
I was like 44.
David! Whoa! And a hush came over the crowd, and David had a question. Lauren? Kira? 34? Oh, you rascal, you. You're going to make me write all these again. David, do you want to change all those into decimals or fractions? I'm going to change them into decimals. So I got negative point. I'm going to do this without writing them down twice, David. I know that 3/8 is 0.375. Okay? I'm comparing that to negative 0.450. Which one of those is greater before we start, David? Negative 375 or negative 450? Which one's greater? Negative 375. Because it's as you go into the negatives, the smaller the absolute value, the greater the number. So 34. The only other thing I have to figure out, David, is what would 5/12 be? Did you do that? Did you do 5 divided by 12? You you should get 0.41. And your next number after the 0.41 is going to be higher than 5 or less than 5? Okay, so you're going to round that one to 0.42 for the purposes of this operation. So now you're comparing, these are all negatives. 0.45, 0.375, 0.42, 0.4, and 0.46. And since they're all negative, David, your least of those is going to be the biggest number. So you're comparing 0.45, 0.38, 0.40, and 0.46. Put those in order, and the smallest of those is going to be the largest absolute value.
Now I'm only on 40. How are you guys on like 49? I'm probably not going to do it before I have to go.
Yes, ma'am.
Yes.
Iceberg, right ahead. When an iceberg broke free from Antarctica in May of 2002. Okay. Area. What is area? Length times width. So the iceberg was 34.5 miles long, 6.9 miles wide. About how much area did it cover? You know why they said about? Well, not estimate, but they didn't say the iceberg was a perfect rectangle, right? So since the iceberg wasn't a perfect rectangle, and they gave us its dimensions, we say for sure that that's the exact square miles, right? So all you're doing is multiplying those two numbers. 34.5 times 6.9.
Do I actually have to do this, or can I like change it?
And that's number,
I make it one negative or something.
what number was that?
Okay, position. 46. No, I hate position.
What'd you get, Elise?
I can't believe that it wasn't going to 3. I'm so confused. Yeah, 137. No, you can be happy because you're like, yeah, what's that?
238.05 square miles. That's a big iceberg. Much bigger than what sank the Titanic. What?
I haven't seen it.
I understand the point. I don't understand.
Actually, we're going to divide, right? Ladies and gentlemen, mic up. When your teacher says ladies and gentlemen, ladies, that means you stop talking. Number 45, you're finding area, you multiply, length times width. Number 46, what do you do there? If you divide, because it's telling you that the tiger compared to the house cat is 4.25 times the mass, so you got to divide that to see how much the house cat weighs. Because think about it, Elise. If you multiplied those two numbers, you'd get a really big number for the size of the mouse cat, and that wouldn't make sense. Right? No, what did I say? The house cat. The house cat. The house cat. Hey, my favorite show was Tom and Jerry growing up. So, mouse cat. Did you ever watch Tom and Jerry?
Yes.
It is. I know, that's what makes it better.
I wish there was sound. There is sound.
Music.
They're just not talking.
Okay, Popeye was there too. Popeye, Tom Jerry. Popeye introduced me to spinach. I ate spinach only because of Popeye. Because otherwise I would never eat something called spinach.
If you eat spinach,
Just like I would never eat something called yogurt.
yogurt.
And I love both of them.
Ew, I don't like spinach. I like yogurt. But spinach will make you strong like Popeye.
Yes.
I can't eat a lot of yogurt. I have to have a small spoon. If you want to be strong, ladies and gentlemen, just eat your spinach greens.
Yes.
Words of wisdom from Dana.
That sounds like a blog.
What?
You could write a blog.
Unless you think of some other one.
There's words of wisdom from Gina. Eat your spinach.
And then the rest of it is
Okay, 29 through 50. Monday, we'll open up chapter 6. Thursday is a big test.
Thursday?